Okay, so now that you have the idea, and hopefully this has jogged your memory, let's talk about a couple of slightly more complex ones. They're not really any different. They just have some fractions or maybe some pi symbols there that sometimes make us a little bit more nervous than they should, because they really don't really change how we solve this problem. So let's try number 4. So number 4, our goal is still the same. That's the beauty of this. Whether they look really simple or a little bit more complex, our goals and steps are still the same. We have an equation. We have a variable t here, so we know this side on the left has to be equal to the one on the right, and there's my variable right there, is the t. So I want to rewrite this so that at the end I just have a statement, for example, that says t equals something or other. And so my goal is to get this t by itself. So now I'm going to pay attention to what did they do to that t mathematically so that I can undo it or do the opposite. So it looks like they are adding a positive 3 over 2. And I know that to 0 or cancel that out, I can do the opposite of that, which is a negative or minus 3 over 2. And I now remember, if you didn't before, that I'm allowed to do that on the left as long as I do the exact same thing over here on the right. Okay, here these are opposites and will cancel. We'll have that t come straight down, and now it's by itself. That's the good news. We still have our equal sign. So really the big question is, what do we get over here? Well, the good news is, yes, they had fractions, but they have a common denominator already. So that's really good news. If we need to kind of come over here to the side, we have a positive 1/2 minus 3 over 2 or 3/2. I already have a common denominator. That's great news. That makes this problem a lot less intimidating than maybe it started off looking like. So I can go straight through and just do 1 minus 3, or 1 and a negative 3, and get that answer. So 1 minus 3 I know is negative 2. My denominator stays. So notice why I just brought it over, straight over. Since they were already a common denominator, I could just bring it over and just do the math with my top numbers, or my numerators. 1 minus 3 is negative 2. And so this is my answer. But recall, we do want to leave our answer simplified, and I know that 2 over 2 is just 1. So this really is just negative 1. That's our answer for t. And then this one might even look a little funky because it's got that symbol. You probably recognize that as pi. What I want to remind you about pi is that pi is just a number. It's actually not a variable. I know it might be tempting to think that that's a variable because it doesn't look like a number, but it's a symbol that represents that number you tend to use with circles at 3.14, so on, so on. So it's really actually a number. And this is still our variable over here. And f is still what we're going to focus on isolating or getting it by itself. So if we have the f here on the left and they added 3 pi, again my goal is to get that by itself, so I'll do the opposite of adding 3 pi, which is to subtract 3 pi. If I do that on one side, I have to do it on the other. That's the most important concept I want you guys to walk away with, is that if you do it on one side, you have to do it on the other. And as long as you keep that balance, it's hard to get this wrong. Okay? And then we have the f is still there. It comes down into our next line, but the 3 pi's, they canceled. I had 3 pi's, I subtracted all of them or got rid of them all. That guy's gone, right? So we just have the f, which was our goal. That's why we did this, because it gives us our goal. Equals, and then on this side we have 7 pi minus 3 pi. So think about that. If you had 7 pi's on a table and you take 3 of those pi's away, how many are you going to have left? You're still going to have 4 pi's, right? That's exactly how this works. Those are what we call like terms, and we've been reviewing that, and we'll review it again a little bit more in the next few days as well. So this is our solution here. F is equal to 4 pi, and it is perfectly okay to leave that like that. Okay, let's try a word problem before we go on to multiplication and division. So let's take a look at number 6. It says the balance of an investment account is $308 more than that balance was 4 years ago. The current balance of the account is $4,708. So what was it 4 years ago? So this is what we don't know. We might call that our x. The balance 4 years ago might be our x, or our unknown quantity. That's what we're trying to find. We don't know what it is right now, so we're going to use a variable to represent that. Okay, so let's say we start with that. I say, okay, well, I don't know what that x or what it was 4 years ago, but I know that the balance now is, so this is our balance now, right? $4,007 is $308 more than 4 years ago. So it's this quantity plus $308 will result in the current balance. That's the idea. So the balance now is $308 more than whatever it was 4 years ago, which is our unknown value. So we didn't have as much money before. We started off with some amount, we're increasing it by 308, and then that'll give us our new amount. So there's our equation right there. That's the first part. That's probably the most important part, and that's what I'll be looking for and valuing the most when I'm looking at your work, is that you can set up the problem initially. And then after that, it becomes just as easy as the stuff up here. But this is my point, right? This is great, and it's so important, but you could be really great at solving an equation, but if you can't apply that in a problem to use it, then it's not as great or as useful of a skill, right? So now that we have our equation, then we can start to solve. We can say, okay, how much was this? Well, if we have $308 more now than before, then let's take that away and find out how much it was before that increase. How much did we have before that happened? That's what we're trying to find out. So we take that away to get to what we had then, and then we can subtract here on this side. 8 minus 8 is 0, 0 minus 0 is 0, 7 minus 3 is 4, and that 4 comes straight down. So that means that we must have had $4,400 4 years ago. That must have been the balance in the account. So the balance was, it's a word problem, so we'll answer with a full sentence. So the balance was $4,400. There you go. That's the proper way to write that problem. So huge things I'm going to be looking for throughout the year is, especially in word problems, is that you set up the equation and I can see it. I can see your work, how you solved it. And if it's a word problem, then you give an actual sentence answer. Okay? All right. So that's all one-step equations, and all of those involve multiplication and division. The good news is you can also solve one-step equations those involve addition and subtraction, and now we're going to multiplication and division, and we can always solve equations almost just as easily, because it's still just all about these being opposite or inverses of each other, and our goal still getting that is to still get that variable by itself. Okay, so the multiplication and division properties of equality give us the same tools to solve. They tell us that if you have two sides that are already equal, you are welcome to multiply by any value, but as long as you do it on both sides. And as long as you do that, the equality or the balance is still preserved. And same thing happens with division. If you know that A is equal to B, then you can take that left side A, divide by any values like C. As long as you divide it on the other side, you're still okay. For multiplication and division, you don't want to use 0. That does get into a pickle, but anything other than 0 is fine. Okay. And then the other good news is these are opposites of each other, so we'll use them, as opposites to cancel things out when we need to. So let's take a look at that in action, and I am going to go a little bit faster now that we have most of the basics here reviewed. So I've got 7 times q is equal to 35. My q, or my variables on the left, this is the side that I want to pay attention to. What did they do mathematically? So I can do the opposite. So since they multiplied by 7, I'm going to do the opposite, which is to divide by 7. Notice I'm not changing the sign. I'm just changing or doing the opposite operation. And so this was multiplication. The opposite is division. And if I do that on one side, I have to make sure I do it on my answer on the other side as well. Okay. Now when we divide, 7 divided by 7 is just 1, or 1q. So that basically cancels that, because 1q is the same as q. And on the right, it's going to reveal our answer. 35 divided by 7 is just 5. So there's our answer. Q is equal to 5. And you can test it. If I put a 5 in here, if I did 7 times 5, does that actually give me 35? The answer is yes, it does. Okay. One thing as we're going through these that I want you to notice is it doesn't completely disappear, but we very rarely use this sort of traditional elementary school division symbol anymore. Little by little, as you get into this higher math, you'll see this bar, and that'll be an indicator of division. So just keep that in mind. So skipping over right to number 10, we've got n is divided by -2. And so I want to get that n by itself. And if they divide it, I'm going to do the opposite of that, which is multiplication, right? So I'm going to multiply on both sides by that same -2, but I'm going to multiply here. And if I do it on one side, I've got to do it on the other side. Okay, now here you might be tempted to actually multiply that, but remember, the whole point is that this operation is the exact opposite of that division, so they're actually just canceling each other and leaving me with the n. On this side is where really things are going to change, because I'm going to have my new and correct answer. If I do a -15 and a -2, I know that a negative times a negative is a positive, and 15 times 2 is 30. Remember, I don't want calculators anytime in the near future, so make sure that you're using just your amazing noggin or head to do your math, okay? I promise it'll pay off later. All right, so there's your n, and then you can always test it, right? We can throw a 30 up here and find out, does 30 divided by -2 give us -15? And the answer is yes, that is the right answer. All right, ooh, how do we do this with a fraction? Well, let's talk about that. Here, if they're side by side, we know that's multiplication. So we've got 3/7 times m is equal to 6. So the opposite of multiplying is to divide, right? Except, hopefully, that's kind of going off a little alarm in your head and say, wait a minute, divide a fraction? We don't really ever divide a fraction. And you'd be absolutely right. We don't really ever divide by a fraction. Instead, if you recall, we do the keep, change, flip, or in other words, we multiply by the reciprocal. So if we're multiplying by 3/7 and I want to do the opposite of that, instead of dividing, is to actually multiply by the reciprocal, which is the flip. And if we do it on one side, you know the drill, got to do it on the other side, right? So these guys will cancel because we'll get 3 times 7 is 21, 3 times 7 is 21, we'll get 21 over 21, which cancels. Okay, so that's why we multiply by the reciprocal. Those cancel, and we get m. Our real new answer is going to be over here, right? If you helps, you can turn that into a fraction. And again, we'll multiply our top numbers here. 6 times 7 is 42, and 1 times 3 is 3. Does that simplify? Of course it does, and I will always expect you to simplify your answer. So actually 3 does go into 42, a total of 14 times. That's our answer there. M is equal to 14. There it goes. Okay, and then last but not least, one with those pies, just so that they don't look too intimidating for you. Look through and say, okay, we got -108 pi is equal to 6 pi j. That's actually our variable, even though I know it's kind of tempting to see these guys. So there's our variable right there. And they're multiplying by 6 pi. So what's the opposite of multiplying by 6 pi? To divide by 6 pi. So I'll divide by the 6 and pi here. If I do it on one side, I have to do it on the other side. There's 6 pi there. So here, the 6 pi cancels the bottom one. That leaves me with the j by itself. On this side, let's talk about this. Well, the pi still cancels because that's still the same thing over itself. So that's good news. So really the only thing we need to figure out is, what is 108? In this case, negative, but what's 108 divided by 6? Well, I know that a negative divided by a positive is going to come out negative. So I'm actually going to knock that out of the way so I don't have to worry about it. And I even can ignore it here if that helps me out a little bit. I'm really just going to figure out what that number is. I already know my answer has to be negative. So 6 does not go into 1, but it goes into 10 once. A little review here. 6 times 1 is 6. We subtract. We bring the next number down. Does this look familiar? Hopefully it does. And then we do it again. 6 goes into 48 8 times, because 8 times 6 is 48. And when we try to do that difference, we get no remainder, so this went in nice and easy. It is 18, and oh, that's right, it's a negative. That's the nice thing about writing it right at the beginning, so that then you can focus on this and not have to worry about later on forgetting about the sign, because you already wrote it. Anytime you do a negative divided by a positive, it's going to be negative. So we've got j is equal to 18. There's your solution. Oh, negative 18. Almost missed that. Okay, negative 18. There it is. Okay. All right. Let's finish off with number 13, and then what we'll do is when you come back to class, which we'll do a couple of these in class together as kind of our little reteach warm-up in class tomorrow, okay? So let's try number 13. We'll finish off with this one. After a party, you have 2/5 of the brownies that you made left over. There are 16 brownies left, okay? You want to write and solve an equation to show how many brownies you originally made for your party. Okay? So we don't know how much you originally made. So how many did you make for the party? That part right there is our x, or any variable you want to use. You could use b or y. Just avoid letters that look a lot like numbers. Okay, so I like to use x a lot. So we don't know how much we originally made. But after the party, there was 2/5 of this left. So that's multiplication. So 2/5 of however many I had originally made is what was left. And that amount ended up being 16. So it tells me how much is left as a fraction of the original. And it also tells me how much is left like the actual number. So the 2/5 that are left is 16 brownies. So those two quantities, there's our scalar balance, right? They're equal to each other. So there's our equation, and now we can solve that. So this one's a lot. Once you set it up, you realize it is a lot like number 11. And we are going to just, since this is multiplication, again, typically we'd say, oh, the opposite of multiplying is dividing. And that's true, but with fractions, we don't actually ever divide. Instead, we multiply by the reciprocal, which is, again, flipping your fraction around. There it is, okay? And on this side, this will cancel, the 2/2, the 5/5, or you could even multiply it out and get 10/10. It's still going to cancel. So we just get x. This is where we really have our new value here. We know that 16 times 5, and if it helps, again, you could put this over 1 if that helps. So you're going to multiply numerator times numerator and denominator times denominator. So 16 times 5, we know is 80. And 1 times 2 is 2. And then you don't want to leave that. We know that 80 is divisible by 2. We know we can do 80 divided by 2 and get 40. So that's really, that simplified answer is the one that I really want. So that must have been how many brownies you originally made. So we'll say, it says how many brownies did you make for the party? That should say, did you make? Show how many you made. Oh no, that's right. So I would say I made 40 brownies. There it is. All right. So those are one-step equations. In every one of those examples, it only took one inverse operation applied to get the variable isolated. We either had to, if they divided, we had to multiply. If they had multiplied, we had to divide. If they added, we subtracted. If they subtracted, we added. But in one step, one inverse operation, it got us to the solution. That's why we call them one-step equations. And our goal is always to isolate that variable. This is modeling how to show your work and what I'm looking for. And we've got a couple of word problems, so we're not going to do this one. This one's kind of, it's got a little bit of a weird wording, but we'll shoot for doing 15 and one of the geometry ones in our next class.